third type of indexing, that is secondary indexing. So if you look at the index matrix, you will find that the unsorted data with key values and without key values, in both cases secondary index is defined. So that means if my database file is having data which is not sorted, and also at the same time it can be unique as well as it can be non-unique. So my database file, if the database file is unsorted, that means it is unordered and at the same time it is having values which can be unique or it can be duplicate. So in both cases we will use secondary index. So unordered or unsorted data with key value and without key values, in both cases only secondary index is defined. So we will understand the concept of secondary indexing with the help of an example. So I have a table with three attributes: employee ID, employee name and PAN number. I have stored the data in the hard disk. Now here you can see employee ID is a key value because employee ID will be unique for every employee. Here name is such attribute which is non-unique. It can be duplicate. And then we have PAN attribute. So PAN number of any employee will be unique, but at the same time it is unordered. It is not sorted. So this database file is having key values, it is having duplicate values and also it is having ordered or unordered data. So such database file if exists, so secondary index means we are using a second index table, but primarily we will be using the primary index table. So I have the primary index table here. So for each block I will make one entry 1, 5, 9, 13. So block pointer with search key 1 will point towards first block. Block pointer with search key value 5 will point to the second block, and block pointer having the search key value 9 will point to the third block and so on. So this is my primary index file. So this we are already using and the search key is employee ID, because employee ID is a primary key for that table. So it will be having sorted values, also it will be having unique values. Now sometimes the situation arises when the query is not written based on the primary key. Sometimes the queries are based on other attributes that are present in the table. For example, select star from employee where PAN number is equal to 30. Now if such queries are processed, in that case employee ID is not included. So my primary index file will be of no use. So in that case we will create a secondary index table based on the attribute PAN. So my search key in the secondary index file is PAN number. Now you see in the original database file the PAN numbers are unordered, but at the same time PAN number is a unique value. So I have two cases here. One, when the data is unsorted and is having key value. This is my first case. So we are trying to understand the case number 1 in this example, when my data is unordered but unique. So what I will do, I will create a secondary index table for this database file and my search key will be my PAN number. Now I will sort the PAN numbers, and based on the sorted PAN numbers I will make my entries in the index table. So here I have PAN numbers for each employee. I kept individual entry for all the employees in my secondary index table also. So it is dense. Why it is dense? Because for individual record I am having individual entry in my secondary index table. One difference is I have sorted all the entries, because if you are using that attribute for searching the record, then it has to be sorted. So we will sort the entries in the secondary index table. Now whenever the query will come, if search key value 10 is required, the reference will be given for this record. Again, if the query comes and it is asking for the record with PAN number 30, then the block pointer will point to the record with PAN number 30. Likewise, for PAN number 40, again the pointer will point towards the record with PAN number 40. So this is how secondary index will work for database file which is having unordered but unique data. So in that case, what will happen? What will be the time complexity? For searching the index file, log base to n, where n is the number of blocks that are present in my index file, plus 1, because once you find the required key, then the pointer will take you to the particular desired record. So for that 1 is added. So this is the complexity in case when we have the data unsorted and unique in secondary indexing. Now we will understand the second case where secondary indexing is defined. So the second case is when your data is unordered as well as it is having duplicate values, that means non-key and unordered combination of data. So here in this example you see we have one attribute name. So employee name is having values that are unordered and at the same time the values are duplicate also, because we can see that multiple employees are having same name A, again employee with name B, employee with name C, B. So with the same values duplicate records are present in my data file. So again we will define secondary index for such data. So I will create a secondary index file with two attributes, search key and block pointer. Now my search key will be the employee name. So here I have employee names which are duplicate, but in the index table I will keep only single entry. So A, B, C, D, E, F. I am keeping only single entries in my index table. So whenever a query comes, for example select star from employee where employee name is equal to A. So what will happen in that case? In that case my index table will be searched and then the block pointer will point towards an intermediate layer. Here we have an intermediate layer which will be having blocks, and each block will be having record pointers. Suppose this block is for value A. So the block pointer in secondary index table will point towards this block A, and here in this block we will be having the record pointers for each record. So if it is a block for value A, then this record pointer will point towards this record. Again this record pointer will point towards the second record with the employee name A, and this record pointer will point towards the third record with employee name A. So like that, for each value in the search key we will maintain a different block at the intermediate layer, and in the intermediate layer we will be having blocks which will accommodate inside them the record pointers which will refer to the individual records. So this is how secondary index works for database file with non-key and unordered values. Now let's look at the complexity of this. So if I look for any record, my secondary index file will be searched. For that we will apply binary search. So log base 2n, where n is the number of blocks that are present in my index file, plus 1 in order to reach the target block in the intermediate layer. After reaching the intermediate layer, from here we will get the record pointer. So for that I will need some additional time. So in this case the complexity will be log base 2 n plus 1 and plus 1. So the complexity is more, and here the index is sparse and here the index is dense, because for each record we are keeping record pointers.